Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday Night Math Night. I am so excited to see you all here. So if you're new to us, we do this every Wednesday. Like Dr. A said, I've got about 10 problems we're going to go over. And if you have any questions, please don't hesitate to ask. That's why we're here. We're here because we all are a community and we're all here because we need help with math. So don't hesitate to ask because I'm sure the question you're thinking of is something that someone else is wondering as well. That said, before we get started, I always like to get to know who is in the room. It helps me kind of guide our conversation tonight. So I do have problems that range K through 12. But that said, I just kind of like to get to know who's in the room. Hey, Easter, good to see you. So in the comment box, let me know where you're from, what test you're prepping for, and what's my get to know you question today. Where are you from? What test are you prepping for? And are you a Gatorade or a Powerade person? Such a random question. We are Powerade people in our house. I don't know why. We just are. We just prefer Powerade over Gatorade. Or do you just not care about Gatorade or Powerade? There's so many other companies out there that make electrolyte drinks now, I feel like. So maybe you're not either. Hey, Bernadette, good to see you. Now, you are going to see quite a few problems tonight that were specifically requested by people in this community. So if you are prepping for your exam and you're like, man, I'm really struggling with this problem, like maybe you have a prep book or maybe you are going through our boot camp and you just are struggling with a specific problem or a specific kind of problem, please feel free to email me those questions or find me on Facebook and send them to me. A lot of the problems tonight are because people specifically requested them, and I am happy to do that. So please let me know as we're working which problems you would like to see me work in the future. Now, I will say we had so many requests from the comments and from emails that I am not going to be able to get to all of those requests this week, but next week I can assure you that we will get to the rest of them, and we'll just kind of prioritize it like that. Hey, Wendy, I'm glad to see you. Hey, Terry, good to see you. Good to see some faces I haven't seen in a while, preparing for the Math 115. Awesome, fantastic. And happy late Valentine's Day, everyone. Happy late Valentine's Day. Let's just draw a big heart. Happy late Valentine's Day. Know that I love you and there is love in the world for you. So happy Valentine's Day. All right, let's get started with problem number 1. All right, so this problem says, what can we conclude? Hey, Joseph, good to see you. What can we conclude about the lines that are graphed to the right? So we immediately see, before I look at my answer choices, that we have line A and we have line B. And what can we conclude about these lines? A, line A does not have a y-intercept. At first glance, it doesn't look like line A does have a y-intercept. B, lines A and B are intersecting lines that are not parallel or perpendicular. C, lines A and B are parallel. D, lines A and B are perpendicular. Thank you. So I can immediately get rid of 2 of these answers without doing any math at all. Which 2 answers can I get rid of right away? I can get rid of C, lines A and B are parallel. These are not parallel lines. The definition of parallel lines is non-intersecting lines, lines that do not intersect. So these are not parallel because they most certainly intersect at that intersection point. They cross. So they're not parallel. And line A does not have a y-intercept. Unless it's a straight up and down line, every line is going to have a y-intercept. And unless it's a line that's straight across horizontally, every line is also going to have an x-intercept. It's just a matter of whether we can see it or not. This line is going to go on forever and ever and ever this way. And it's going to go on forever and ever and ever this way. And we can see that it's getting closer and closer and closer to that y-axis. And it's eventually going to cross it. It's just going to cross it way down here. Doesn't mean it doesn't have one. A line is an infinite function that goes on in both directions. So I know that line is going to have a y-intercept eventually. We just can't see it. So like I said, unless the line looks something like this, where it's literally going straight up and down and it's never going to cross that y-axis, all lines have a y-intercept. And unless the line looks something like this, all lines have an x-intercept as well. So lines A and B are intersecting lines that are not parallel or perpendicular, or lines A and B are perpendicular. So really we're trying to figure out, are these lines perpendicular or not? Because that's the only difference between B and D, is whether it's perpendicular or not. Well, let's define what perpendicular is. Perpendicular lines are lines that cross at a 90-degree angle. Now, I could look at this and be like, man, that kind of looks like a 90-degree angle. Done. They are perpendicular. We cannot assume anything based on the way they are drawn. Ever, ever. If that's the one thing that you take away from tonight's session, I will be thrilled. We cannot look at a picture and assume anything. We have to use the information given in the picture. So for instance, if they gave us a triangle that looked like this, and that's all they gave us, we cannot assume that this is a right triangle at all, because they did not tell us that that's a right angle. However, if they gave us a triangle that looks like this, even if they didn't say it's a right triangle, we can assume that those are perpendicular lines because it creates a 90-degree angle, but that it is a right triangle because they gave us a piece of information to tell us that. So that said, just because it looks perpendicular doesn't mean that it is. What do we know about lines or linear equations and their slopes? Parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. Now, I know that that's like kind of a crazy, crazy vocabulary. Excellent, Bernadette. That means that if the slope of line A is, and I'm going to use different variables. If the slope of line A is x over, those are terrible variables too, s over t, then the slope of line B is going to be negative t over s if they are perpendicular. So I need to figure out the slope of line A and the slope of line B. How do I do that? In this case, I'm going to count because I've got a graph to do it. So I'm going to find two intersection points. I have one here. I have one here. I have one here. So there's three. So I'm going to check my slope. Slope is rise over run. So rise 1, 2, 3, run 1. Let's check it again. Rise 1, 2, 3, run 1. So the slope of line A equals 3 over 1. How do I know if it's positive or negative? Well, I rose 3, that's positive, and I ran to the right. So that's also positive, which means it's positive. Now, what if I went like this? 1, 2, 3, run 1. In that case, I'm running negative 3 down, but I'm also running negative 3 to the, or negative 1 to the left. So a negative over a negative equals a positive. So slope of line A is 3. That means in order for these to be perpendicular, the slope of line B would have to be what? Negative 1 over 3. So let's see. Let's look for some intersection points. There's one, there's one, there's one, there's one. So let's go. Rise 1, run negative 2. Rise 1, run negative 2. So in this case, my slope is negative 1 over 2. Are those negative reciprocals or opposite reciprocals? They are not. Are they opposites? Yeah, one's positive, one's negative. And they are close to being perpendicular, but they are not perpendicular. All right, let's move on to problem 2. All right, if it's highlighted in pink, that means that it is a problem that was specifically requested by someone in this group. So someone specifically sent me a problem that was similar to this, and I recreated it so that, for multiple reasons, but one, for copyright reasons, 2, so that this individual can now solve a problem just like this on their own in their own study material. So, to the person who sent this to me, thank you. We can all learn from it. Joseph has a rectangular pool in his backyard. If you have been with me for longer than 2 seconds, you know, as soon as I see that, I'm going to draw a picture. So here's my rectangular pool. Well, that didn't work the way I wanted it to. Here is my rectangular pool. And it is 12 3/4 feet wide by 7.5 feet long. Now, what if you drew your pool like this? And you said this was the 7.5, and you said this was the 12 3/4. Is that okay? Absolutely. All it is a flipped rectangle, so it's not a big deal. So it doesn't matter which one we use, it still works. So let's go ahead and continue to read the question. The pool measures 12 3/4 feet wide by 7.5 feet long. What is the area of the pool? All right, let's quickly talk. What does area mean? Area is the square measurement on the inside. Square measurement on the inside of a 2D shape. So how many squares can fit inside a 2D shape? So the formula for area of a rectangle equals length times width. So I'm going to do 7.5 times 12 3/4. There's a couple of different ways that I can do this. I could convert this into a decimal. I could convert this into a decimal. I just know that a half is 0.5. A half of a dollar is 50 cents. So I could do 7.5 times 12 and I know that 3/4 of a dollar is 0.75. I'm telling you right now, if you can remember some of those really common anchor fractions and their fraction to decimal, decimal to fraction relationship, it's going to save you a lot of time, especially for a problem like this. Now, instead of having 7.5 on the top, I'm going to flip that and have 12.75 on the top, just for pure preference reasons. So 12.75 times 7.5. Now, if you had a calculator, I would just do it with your calculator. So I'm just going to sit here and go la-di-da-di-da-di-da-di-da-da, 12.75 times 7.5 equals 95.625, which is D. However, that's not, if this was on an elementary test, you're not going to have a computer. So I'm going to do it the long division way. 25, 35, 36, 37, 13, 6, 0 placeholder, 35, 49, 50, 51, 52, 14, 15, 16, 17, 18, 19, 8. Add them together, 5, 2, 12, 6, 15, 9. Because there are 3 places being held by a decimal in the problem, that means I'm going to have 3 places held by a decimal in my answer choice. Now, here's probably one of the more common mistakes people are going to make. They're going to do 12 times 7, and then they're going to do a half, which is 84. And then they're going to do a half times 3/4, which is 0.375. Unfortunately, that's not going to work. Because of the way that fraction multiplication works, that's just not going to work for our purposes for this problem. Because when I multiply a half times 3/4, what I'm really saying is, what is half of 3/4? So it totally skews the fact that we actually have 7.5, and we have 12 3/4. We're not trying to find half of 3/4. Does that make sense? So that's why when you're multiplying mixed numbers, that just doesn't work, okay? All right, let's go ahead and move on to the next problem. Which of the following inequalities is equivalent to the inequality below? 3x plus 5 is less than or equal to 8x minus 3. So this is another problem that was specifically requested, or a type of problem that was specifically requested. So let's go ahead and solve this. So which of the inequalities is equivalent to the inequality below? Now, here's the thing, and here's what I want you to realize. I'm going to use my answer choices to help me. When I look at my answer choices, I have x is either greater than or less than a certain value for all of my answer choices. So that means what I'm really doing is solving for x, okay? So I need to get all of my x terms on one side of the equation and all of my non-x terms on the other side of my equation. So to do that, I'm going to subtract 8x from both sides. Could you subtract 3x from both sides? Yes, and I will solve it that way on this side over here. I'll do that in a minute. So by subtracting 8x from both sides, I get negative 5x plus 5 is less than or equal to negative 3. I'm now going to subtract 5 to both sides. And I have negative 5x is less than or equal to negative 8. Now I'm going to divide by negative 5 on both sides. And I'm going to get x is less than or equal to positive 8 over 5. However, I want you to realize that that would be incorrect. When I multiply or divide by a negative number, when I multiply or divide by a negative, it just disconnected on me. By a negative number, what ends up happening is my symbol flips. What ends up happening is my symbol flips. Does that make sense? So what's going to happen is instead of less than or equal to, I'm going to be greater than or equal to, okay? So when we look at this problem, when I divided by that negative 5, what ends up happening is that symbol is going to flip the opposite way, and that would be my answer. Now, if I had subtracted the 3x to the other side, hey, Arlene, I'm glad to see you. I believe I'm doing one of the problems you asked me for right now. So if I had flipped and done the 3x, I want you to see this. Subtract 3x from both sides. 5 is less than or equal to 5x minus 3. Add 3 to both sides. 8 is less than or equal to 5x. Divide by 5. My symbol is not going to flip. 8 over 5 is less than or equal to x, or x is greater than or equal to 8 over 5. If we think about it like an alligator, the alligator is eating the x, no matter where the x is. So in my answer choices, I need to find an answer that's showing the alligator eating the x and not the 8 over 5. So that means that my answer is going to be D. Now, what if all of that didn't make sense to you and you saw a problem like this? You could totally pick a value and plug it in. So if I picked a value of 0, that would mean that I would have 0 plus 5 is less than or equal to 0 minus 3. Is 5 less than or equal to negative 3? Absolutely it is. So if I picked 0, that means that 5 would have to be less than or equal to negative 3. And then I can look at my answer choices to determine which of those inequalities makes the most sense for my problem. So it's just another strategy that we can use. All right, let's move on to the next problem. Another problem that was specifically requested by a member in this community. And unfortunately, my computer is about to die. I think I need to get a new battery because it was fully charged before I jumped on here and we've only made it 25 minutes. So I'm trying to think of the best way to do this. How would I graph that? That's an excellent question. So if I was to graph this, x is greater than or equal to negative 8 over 5, I would have 0, 1, 2, negative 1, negative 2. 8 over 5 is going to fall somewhere in between 1 and 2, right? Because 8 divided by 5 is exactly 1.6. So because if this was 8 over 5, then I would have a closed circle because it's greater than or equal to, and then x is bigger than or greater than 8 over 5, which means that my graph would go this way. So that was a great question. And you know what? I will go ahead and add that to next week's sessions so that we can work on graphing inequalities as well. That's a great suggestion. All right. I'm going to figure out how we can continue on without me using this massive cord that I'm using right now. So we may just have to do this Let's look. You just won't be able to see me. You're just going to have to look at the screen because the way that we have it like plugged in, like my computer is plugged into my TV, but I only have one port to plug everything into, and it's my charging port. So like when my charger or when my computer is about to die, I have to unplug the TV, which is what connects the iPad. So let's just do this for today. We're just going to make it work, right? When the variable is on the left side, the graph and the inequality go in the same direction. That's a great point. Okay, it's not the best, but you know what? It'll work. Can you all see this screen? Just give me like a thumbs up or like, is this going to work or should we just stop? Let me know. All right, in the figure below, all the small rectangles contained in rectangle A, B, C, D shown have the same area. How many of the small rectangles must be shaded so that 42% of the area of the rectangle ABCD is shaded? Now, I need you to realize that, again, this is a very specific problem that someone asked for. In fact, someone sent me a problem very similar to this, but it actually covers two birds with one stone because someone also asked for percentage word problems. So this is like a double whammy. So let's go ahead and read this again. In the figure below, all the small rectangles in this larger rectangle have the same area. How many of the small rectangles must be shaded so that 42% of the area of the rectangle is shaded? Now, what is a percent? A percent, all a percent is a part, and forgive me because I'm going to be writing upside down, of a whole. A percent is a part of a whole. So if a percent is a part of a whole, and this is my whole, I need part of it. I need 42% of it. So let's think back to the idea that fractions, let's undo that. Fractions, which is like a half, can equal a decimal, can equal a percent. So if I can get this into a fraction, then I can also get it into a percent. Or I can use my understanding of percents to solve it. Let's figure out how many rectangles there are total. So I've got 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the top. So I have 5 on the side and 10 on the top. That means, because remember, area equals length times width, right? So if area equals length times width, then I can do 5 times 10, which equals 50. So the area of this bigger rectangle is 50. What does that mean? I'm looking for 42% of 50. If we think about a percentage word problem, if I want 42% of 50, I can multiply 50 times 42% and get the answer. How did I get 0.42? Because to convert a percent into a decimal, I just hop that decimal 2 places to the left. So if I have 13% as a decimal, I'm going to take that imaginary decimal that's right there, and it's going to go hop. So that equals 0.13. When we convert decimals, or when we convert percents into decimals that look something like this, that's where people start to get confused. Because a lot of people will say that the decimal for this is 14.5, but we still have to move that decimal place 2 places over before we can convert it. So the decimal for that would be 0.145. But all that said, let's go ahead and do this multiplication. So 2 times 0 is 0. 2 times 5 is 10. Add a placeholder 0. 4 times 0 is 0. 4 times 5 is 20. Add it all together. I get 0, 0, 0, 1, 2. And we've talked about this already today. I have 2 place values being held by a decimal. So I'm going to hop the decimal 2 places over, which means 21 squares are going to be 42% of this graph. Now, here's what I want you to think about. I need you to think about if that's a reasonable answer or not. What I want to get you guys used to is thinking about, is that a reasonable answer or not? Because that's an excellent way for you to self-check your work. So, is it a reasonable answer? Well, I know that 50% is half. So if I know that 50% is half, what is half of this rectangle right here? Half of this rectangle is going to be 1, 2, 3, 4, 5. That's half. How many squares is half? Let's count them really super fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. If 25 squares is half, and what we have is 42%, what we need is for it to be just a little bit below half, or 50%. Is 21 just a little bit below 50%? It absolutely is, which means we have a reasonable answer. Excellent job. So, had I looked at my answer choices first, I would have been able to get rid of C. Whoa, that was a really thick line. I would have been able to get rid of C and D because C is 50% and D is going to be over 50%. It's going to be greater than half. So using that information is extremely helpful when you do get stuck on a word problem. Let's go ahead and go on to the next problem. All right. Another problem that was specifically requested, or the type of problem, 1 lap around a rectangular field is 664 feet. If one side of the rectangle is 85 feet, what is the area of the field? So I'm going to read that one more time, and I'm going to draw it. 1 lap around a rectangular field. So here is my rectangle. Not the best rectangle I've ever drawn. Is 664 feet. So that means if I go around the field, that's going to be 664 feet. If one side of the rectangle is 85 feet, what is the area of the field? Now, a lot of us would assume that in this situation, they would be asking us for the missing side, but they didn't. They asked us for the area of the field. So yes, Bernadette, they've given us the perimeter. The perimeter is 664 feet. What is perimeter defined as? The distance around a shape. So if that's the perimeter, that means that this plus this plus this plus this has to equal 664. What do we need to be able to find the area of the shape? What do I need to be able to find the area of the field? In order to find the area of the field, I need a length and I need a width. Well, I have one of them, but I need another one. So I'm going to have to do some backwards work to really figure out what that missing side is. If this side is 85, then I know that this side is also 85. And I know 85 plus 85 plus question mark equals 664. Well, let's go ahead and replace those question marks with variables. X. You could also use L or W depending on what your preference is. So I know that 85 plus 85 plus X. Writing upside down is really hard. Plus X equals 664. Okay, there we go. So 85 plus X equals 664. Now, I know that X plus X is going to be 2X. But I cannot add the X and the X to the 85 and the other 85 because I can only add things that are alike. So I have 2X plus, what's 85 plus 85? I'm going to use my calculator for that. If you were taking elementary, you wouldn't get a calculator, but that's okay. You could always do long addition. 170 equals 664. I'm going to subtract 170 from both sides. And 664 minus 170 equals 494. So 2X equals 494. What am I going to do to finish this? Divide both sides by 2. Absolutely. So I'm going to divide by 2, and 494 divided by 2 is 247. So X equals 247. So that means that this side is 247 and this side is 247. That is not my answer. And in fact, that should be one of the answer choices because that is going to be one of the most common errors that people make is not that they don't know how to do the problem. It's that they're going to choose an answer just because they didn't finish the problem. So let's keep going. Area equals length times width. So we're going to do area equals 85 times 247. So 85 times 247 equals 20,995. Exactly what Jacinth, Bernadette, and Terry all got. Excellent job, students. Excellent job. Always makes me so proud when you beat me to it and you solve it and you get the right answer. I'm like a proud mom. Excellent job, y'all. All right, let's go ahead and move on to the next problem. All right, probability has been a huge question among our little community and has been something that a lot of people want to see. So we are going to go into 2 different probability problems. One is a little bit more simpler than the other. All right. Jocelyn has 7 pennies and 8 nickels in her bag. Again, probability has been a huge question, which is why this is highlighted. 4 of the pennies and 3 of the nickels are Canadian. The others are from the United States. If Jocelyn randomly selects a coin from her bag, what is the probability that it is a penny? 4 out of 15, 7 out of 15, 11 out of 15, or 12 out of 15? So here's what I need you to realize. Probability is just the desired outcome over the total possible outcomes. And I'm going to write that right side up because I want you to be able to see it and remember it. So it's desired outcome over total possible. That's all probability is desire over the possible. So if we're looking at desire over possible, how many possibilities are there in her bag? How many possibilities are in her bag? Well, she has 7 pennies and she has 8 nickels. That's it. We don't have 4 more pennies and 3 more nickels. We only have 7 pennies and 8 nickels. So what that means is we have a total possible of 15. The 4 and the 3 are just parts of that. So if I have 7 pennies, I'm going to make those a little bigger. 1, 2, 3, 4, 5, 6, 7. These are all pennies. And then I have 8 nickels. 1, 2, 3, 4, 5, 6, 7, 8. But then it says 4 of the pennies are Canadian. So this is a Canadian penny, this is a Canadian penny, this is a Canadian penny, and this is a Canadian penny. And this is a Canadian nickel, this is a Canadian nickel, and this is a Canadian nickel. 3 of the nickels are Canadian. Not adding them. So the question is, what is the probability that I'm going to pull a penny? What is my desire? My desire is to pull a penny. How many pennies do I have? 7. So my probability is going to be 7 out of 15. That was a pretty easy, straightforward probability problem. I'm not going to lie. The next one, not so much. The next one is a little bit more complicated. So let's go ahead and explore it. Same story, because I wanted to give you a similar story with a different scenario. So it's the same story. Jocelyn still has 7 pennies and 8 nickels in her bag. 4 of the pennies and 3 of the nickels are Canadian. The others are from the United States. If Jocelyn randomly selects a coin from her bag, what is the probability that it is a penny or it's from the United States? All right. This one is a little bit more complicated because when we talk about probability with and or, what we're looking at is whether it's mutually exclusive or not. So here's where I want you to go with that. If it is a mutually exclusive probability problem and it's an or problem, then we are only going to do probability of A plus probability of B, and that's it. But if it's not mutually exclusive, then it would be probability of A plus probability of B minus probability of A and B. Confusing, I know. Let's look at it. And let me explain mutually exclusive. So mutually exclusive means one cannot happen when the other happens. So if I was to pull out a dime or a nickel, that is mutually exclusive because I can't pull out a dime at the same time that I pull out a nickel. However, if I said, what's the probability of pulling out a dime or a US coin? Could I pull out a dime that is a US coin? I can. So that is not mutually exclusive because it can happen at the same time. If they cannot happen at the same time, it's mutually exclusive. If they can happen at the same time, it is not mutually exclusive. So we have two different formulas we're looking at. In this situation, it is not mutually exclusive. So when we look at this problem, my formula is going to be probability of A plus probability of B minus probability of A and B together. If it's mutually exclusive, then you would be looking at probability of A plus probability of B. Now, this looks confusing. It's not. It'll make a little bit more sense here in a minute. So when we look at the question said, what is the probability that it is a penny? There's A. Or from the United States, there's B. So probability of B is going to be from the United States. Probability A is going to be a penny. Let's go back and remember what probability even is. Remember, probability is desire over total. What did we decide our total is in this problem? We decided our total was 15. Oop, that's a backwards 5. And what is our desire of A? A penny. So that's 7. Plus, what is the probability of B? Our total is still 15. We haven't removed a penny and kept it for ourselves. 15 from the United States. Let's go ahead and go back to our original picture and copy and paste it. That way we can see the visual. I'm a huge visual person if you haven't already figured that out yet. So we're going to copy that and we're going to paste it into this problem right here. That way we can see it. All right. So it has to be a coin from the United States. Well, United States are going to be all the coins with a blue dot. So from the United States are going to be the ones without C's. 1, 2, 3, 4, 5, 6, 7, 8. From the United States is 8 out of 15. But I'm not done. Then I have to subtract the probability of A and B. Well, what is the probability of A and B so that it is a penny and in the US? Well, we still have 15 coins. But now we're changing this to an and. What is the probability that it is a penny and United States? Well, United States pennies is what we're looking for at this point. How many United States pennies do we have? We only have 3 of them. So what is, now in this case, we all have like denominators. So like elementary people, when we're adding and subtracting fractions, that right there is a great thing because we have common denominators. What's 7 plus 8? 15. What's 15 minus 3? 12. So my answer is 12 out of 15. Probability is one of those things like, it's hard because it's something we don't use on a daily basis, right? It's something that's so foreign to some of us. All right, we have time for like one more problem, and then we'll have to say sayonara, see you later, and we will finish the problems next week. All right, here's the last problem for today, and then we will meet back up next week. Here's what I want you to do in the meantime. I want you to think about what you want to see that we haven't done. Here's what I will tell you. We still have percentage word problems on deck for next week, functions and calculus on deck for next week, and indefinite integrals of trig functions on deck for next week. So if you ask for something like that, those are still on deck for next week. We did not get to those. However, if there's something else that you want to see or problems that you're finding in your study guides that you want to see me solve, email me or find me on Facebook and send them to me, and I will absolutely include them. You saw how many problems I included from recent requests. Almost all of tonight was a recent request, and so is this one. All right, last problem for tonight, and then I'll say sayonara. Okay. Now, I chose this problem because the last time I did one like this, y'all were like, so I want to see if we can do it together. For those of you who had like a little, whoa, which of the following best describes the faces of an isosceles triangular prism? Now, remember, we've talked about that a prism has 2 identical bases with rectangles surrounding it. So what kinds of bases do we have? We have isosceles triangle bases. And there will be 2 of them because it's a prism, not a pyramid. So in this case, I can immediately eliminate the answer D and C because my bases have to be 2 isosceles triangles. Now, the trick question is going to be what next? Are we going to have 3 congruent rectangles? Or are we going to have 2 congruent rectangles and 1 additional non-congruent rectangle? Well, if I think about an isosceles triangle, I know that 2 of the sides are the same, and then the other side is not necessarily the same. So if I'm looking at an isosceles triangle prism, then what I'm looking at is a rectangle that has a length that's the same as this length, but then this rectangle has a much smaller length. So we are not going to have 3 congruent rectangles. We're going to have rectangles that match my base. 2 isosceles triangles, 2 congruent rectangles because I have 2 congruent sides on my triangle, and 1 additional non-congruent rectangle. All right, that was fun. We made it work. And I am very thankful that you guys stayed through even though you couldn't see me the entire time. We were just looking at the math problems. That's really all you care about anyways, is those math problems. So in the comments, I'm going to turn it back over to Dr. A. In those comments, let me know what you want to see in the upcoming weeks, or email me and I will share my email on this slide. Email me problems that you want to see, and we will absolutely include them as evidenced by this week. So If you want to see me solve a specific kind of problem, email me or drop it in the comment box below. And I am going to go ahead and turn it back over to Dr. A. Thanks y'all for coming, and I will see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.